We have a geometric progression where the first term is 3. An minus 1 means the second last term, that's 192. And we have our last term that has a value of negative 384. Using these three values, we need to find the sum of the series. So let's begin. So in this particular problem, since our first term that's already mentioned, we'll need to specify the common ratio. So let the common ratio, we're going to represent it by the letter R in lowercase. Now, it's given here that our first term A value that's equals to 3. The second last term An minus 1 that's 192, and the last term An, so that's negative 384. So we know that An, the last term, can be also expressed as A times R raised to the power of n minus 1. So that's equals to negative 384. A value, so that's 3. So we have 3 times R raised to the power of n minus 1. Now this is equals to negative 384. So R raised to the power of n minus 1. So if we divide both sides by 3, we're going to get negative 128. Then we have the n minus 1th term. So we're going to get A times R raised to the power of n minus 1. Minus 1 equals to 192. So we have 3 times R raised to the power of n minus 2. So that's equals to 192, dividing both sides by 3. So that's going to give us R raised to the power of n minus 2 equals to 64. So let's label this as equation number 1, and the other one is equation number 2. Now what we'll divide equation number 2 with equation number 1. So that means we now have R raised to the power of n minus 1 divided by R raised to the power of n minus 2. That will be equals to negative 128 divided by 64. So let's simplify it. We're going to get R raised to the power of n minus 1 minus n plus 2. That's equals to negative. So 64 times 2, that's 128. So we have R raised to the power of, so n goes away, negative 1 plus 2, that will be positive 1. So our value is negative 2. So this is our common ratio. So now we have our common ratio including the first term, which has a value of 3. And we can find out the sum to n term. The sum to n term. Now here we can observe that the common ratio R, so that value is less than 1. So we know we have to use the formula for the sum to n terms of a geometric progression, which is given by A times 1 minus R raised to the power of n divided by 1 minus R. So this holds true whenever R value is less than 1. So this will be equals to 3 times 1 minus negative 2 raised to the power of n whole divided by 1 minus minus 2. So 1 minus minus 2, that's 3. So that means the numerator and the denominator goes away. And this gives us a final value, 1 minus negative 2 raised to the power of n. Now, we can also obtain the value of n here. So we'll keep this value aside. So let's write it down. So we have as n equals to 1 minus negative 2 raised to the power of n. So let's now compute the value of n. So in our question, it's already provided that the nth term that has a value of negative 384. So we know that the nth term, so that's A times R raised to the power of n minus 1 equals to negative 384. So we've obtained our first term. So our first term is 3. Then our common ratio R, so that's negative 2 raised to the power of n minus 1 equals to negative 384. We have negative 2 raised to the power of n minus 1, so that's equals to negative 128. Negative 2 raised to the power of n minus 1, so negative 128, so that's actually 2 raised to the power of 7, which means we can also rewrite this as negative 2 raised to the power of n minus 1 equals to negative 2 raised to the power of 7. So here the base is negative 2, which is equal. So that means n minus 1 must be equals to 7. Solving for n, we get n equals to 8. So we have 8 number of terms present here. So now we can replace this value back into a sum. So that means we have sum up to 8 terms. That will be equals to 1 minus negative 2 raised to the power of 8, which will be 1 minus the negative 2 raised to the power of 8. So that value is 256. Our final value is going to be negative 255. So this is going to be the sum of the given series.